we're getting into this idea of communicating numbers that we know and how certain we are of that. So these numbers are pretty different than numbers you guys talk about in math. In math, you guys are talking about theoretical numbers. Like if you're talking about 1/2, you're talking about exactly 1/2. You're talking about like 7, that number is exactly 7. But in chemistry, we deal with measurements. Measurements are quite a bit different than exact numbers. So it's important to communicate how exact the numbers are. That's the key idea here. So we're going to have to start thinking differently about when we're doing calculations, because we have to do it the proper way. Otherwise, what happens? Your satellite blows up and you're fired, and then you have to find a new job, but you can only make satellites. So you got to go back to plan A and figure out something else. And you're too old to be a baseball player, so So make sure you pay attention to things like these. So a significant figure. Why do we talk about sig figs? Actually, I like to call them measured figures because they're actually things that are measured. A significant figure is a number we know with a certain degree of reliability. So copy that now. So why sig figs? You guys can see these. And actually, the stuff is still back there on the lab bench over there. But this is the exact same object. I didn't open it up. I didn't take out any salt. But one balance right here measured at 177.92 grams. And one measured it at 178 grams. Which one's right? Brennan?
Technically neither, because they can't go to the exact digit that they're at.
Okay. Not quite. They're actually, what do you think, man?
Is it like both of them?
They're both correct. So if you're recording these, you would record the balance, the O-house balance, this one right here, which we use to measure small quantities of chemicals. You would record this at 177.92 grams because this device measures to the hundredths. So we record to the hundredths. Whereas this device, the kitchen balance, only goes to the ones. And also, the other day we brought up the idea of uncertainty. This balance has an uncertainty. The balance on the left has an uncertainty of 0.01, where the balance on the right has an uncertainty of 1. So we have a much more precise balance on the left than we do on the right. Now, why do we do that? Why is it okay to measure some things with our kitchen balance? What do you think, Brent?
Because it doesn't matter too much if you're off by 1 on kitchen balance.
Exactly. We don't need to know the precision when we're cooking to the hundredths of a gram. It doesn't matter. It's not a factor. Whereas if we're making a solution, small quantities of solutions in chemistry, it does matter. And in fact, Mrs. Miller has an analytical balance that goes to the 10,000ths. And if you guys ever go into a jewelry store, they might not have them out, but they have ones that go to the 10,000th as well, because they really want to precisely measure their jewelry because it's so expensive. But if you're talking about a hundredth of a gram of flour in your recipe, not going to make a difference. We don't care about that. Sort of like you guys are on the highway, you drive by these weigh stations. Weigh stations, right, they're always closed. I've never seen one open. Maybe once or twice. But they measure the tons of the trucks. They don't care about the 1 pound. That's not a significant thing. Doesn't matter. What they need to do, what you really want to do is consider what you're doing, the device should reflect appropriately what you're measuring. Like you're not going to go measure small quantities of chemicals on the kitchen balance because it has a high uncertainty. Does that make sense, guys? Okay. So that's why. So each measurement is perfectly fine, but when you're recording it, you need to record it appropriately. So you would record your O-house balance to 177.92 grams, plus or minus 0.01. You would record the kitchen balance as 178 grams, plus or minus 1. Okay? So it's important to report what you know. Okay? So these are a couple rules that we're going to go about how we communicate significant figures. Okay? So write these down. So this first rule is pretty easy to understand. So anytime you're writing a number, if you're communicating it, so if I have the number 124 milliliters, all of these are significant figures. So what you're saying is, I know the hundreds digit, the tens digit, and the ones digit. Or if I have 2.31 grams, they're all significant figures. I know the ones, the tenths, and the hundredths. Also, zeros between digits are communicated as significant, and this should make sense as well. So if I had 104 milliliters, or 2.08 grams, in this example, I know that the hundreds digit's a 1, I know that the tens digit's a 0, and the ones digit is the 4. Because if I'm measuring the ones digit and the hundreds digit, I have to know that this is a measured 0 right there. Same thing here. If I know the hundredths and I know the ones, the tenths must be a 0. They're significant. So in between, all right, make sense? All right. So let's go on to the next rule. Zeros in a measurement where there's no decimal point are not significant. Okay? Doesn't mean they don't matter. So let's consider A right here. 2,500. What this states, and this is how it's communicated, is that I know the thousands is a 2, I know the hundreds is a 5. But what it's saying is my device I'm using to measure is not as precise enough to go to the tens. What these here are called placeholders. They're placeholding zeros. The biggest misconception in the world, maybe not the biggest one in the world, but a really big misconception is that if they're not significant, it doesn't matter. And that's the opposite of the truth. These are extremely important. These are placeholders, placeholding zeros. They preserve the degree of magnitude. So that's important to understand. You can't just get rid of them. They do matter, but they're not measured. Okay? So I want to talk briefly about why 0 is so fun. Okay? So moving forward, 0 is a significant figure. So write this down. I'll give you guys a second. You guys don't have to do the examples yet. We'll talk about those as a class. So why is 0 so special? Because, and it rarely happens, but say, and I did this on purpose, and I made this is the same baking soda. It's still back there in that balance over there. You guys can look at it. I made it exactly so that the total mass was 100. So if we're recording this, it's really important to record it correctly. So if I'm recording, let's see what color we did. So if I'm recording this mass right here in this balance, what should I record? Is it okay to just write 100? What's wrong with that? Why would you be angry at that? Okay?
Because you have to get up to 0 because of the answer.
Grams plus or minus 0.01. I need to make sure that I'm recording this number to the hundredths. Why? Because my instrument measures to the hundredths. What about this one over here? What would I record here? Now this is a funny one. And this is going to get into a new little rule or notation that we use. So this one right here What are we going to record? Right?
100.
100. But as written, 100, these are written in, they're not significant. Joe, what were you going to say? Nope. What, this balance goes to what place? This balance measures to the ones, right? So this 0 is significant, really. I know this is a 0. I know that this is a 0. Right? So what I do in this case, and this is something you guys are going to want to be aware of, put a decimal point after that if it's in the ones. Okay? So if you're at 100 decimal point, that indicates that this 0 is significant, and therefore this 0 is also significant. So you have to record it correctly, and you'd say plus or minus 1. 100 decimal point. There's an old way of doing it that you might see. I rarely saw it in my day, back in my day, but you put a little hat on the 0 to indicate it is a significant 0. So if you needed 3 sig figs here, 100 with the hat. Sasha, do you have a question? Okay. All right, moving on. Does this make sense, guys? If you just consider the nature of the measurements before you record something or before you calculate something, it'll make sense. Eli, I'll get to your question in a second. But what I don't want you to do is just be blind calculators. Just don't go calculate. Think about the calculations you're doing. Okay, that's important. Immensely important. Okay, Eli?
Wouldn't the 2 zeros of the 100 just be placeholders then?
No, they would not be. That's why you can't write it like 100, like this. Because this looks like they're placeholders. Whereas this here, 100, they're not placeholders because this balance is precise to the 1 gram. Okay?
Why do you need to mark that they're not placeholders if you show through your uncertainty that they're not?
For consistency. You need to be consistent. So it would be wrong to write it. It would be wrong to write this 100 plus grams plus or minus 1. That would look like you didn't know what you were talking about. Because this here, you can't have something that's precise to the hundreds with uncertainty that's in the ones. And that's why you wouldn't have it if this was 102 grams or 100.02 grams. And here, if you had it 105 grams, it wouldn't even matter. But the only reason you have to consider that is because you have to differentiate placeholding zeros, like these two right here, from actually significant zeros. These ones right here. These are sig zeros. Okay. So I go a little crazy sometimes. Like the other day, I was in a Stop and Shop, and there were figs for sale, and I was like, "Oh, sig figs." So bad. It's seriously. That's how my brain works now. It's all you guys' fault. So that's why zeros are a little bit weird. Okay. So keep that in mind when you're thinking about it, Shelby.
So, like, how would you tell the difference between a placeholder zero and a significant?
Okay, we're gonna talk a bunch about that. But hold on, let me. How many sig figs are here? 2. The 2 and the 5 are significant. We know the 2 in the thousands. We know the 5 in the hundreds. But what are these ones? These 2 zeros. They're placeholders. They're not. I don't say if something's not significant. If something's not significant, it's not insignificant. So it's just that they're not measured. Okay. How about this one right here? Shelby, how about this number? 1,001 meters. 4. You're right. Saul, how about 125 grams? 3. And lastly, Eli.
There is
How about this 4? Let's go through.
6.
1, 2, 3, 4, 5, 6. Yep, you got it. Nice. move on, and we'll POGO in a minute. So here's a couple good examples that I tried to come up with that had a couple different things that we haven't seen. Noel, how about 2,500? Keep in mind that decimal point. This has 4. The decimal point here indicates that that goes to the ones. That number is precise to the ones digit. Jake, other stream. 2,500.0. 5. If you have a number, a 0 after a decimal point, it is significant. And another number. So otherwise, why would you put it there? If the number didn't require this 0, you just write 2,500 point. How about David W? How about 0.025? 2. 2 and 5. And lastly, this crazy number, Mandy.
Is it 5?
Yep. 1, 2, 3, 4, and 5. Oh, almost. But these zeros are after the decimal and a number, so these numbers are significant too. So I'll teach you guys. Actually, I'll go through it right now. Let me end this. I'll show you guys the rule.